All right. Uh, so far, we have discussed the following topics that we must recap that one. Then we should move ahead. You see, in this chapter, first of all, we have discussed about reflection and all about reflection has already been discussed a lot. I have also discussed about light is an electromagnetic wave or ray that travels in a straight line, and that's why it is called ray optics. This branch of optics is called ray optics or geometrical optics. In this branch, we would study the two different optical phenomena, reflection of light and refraction of light. So far, we have already discussed reflection. When light falls on a surface and is reflected back or bounced back into the same medium, we say reflection has taken place. Next one is refraction of light. So, refraction of light means when light travels from one medium to another medium, it bends from its original path. In nutshell, you can say that bending of ray of light while passing from one medium to another medium is called refraction. Now, in order to learn the refraction in a better way, we must learn the essential term related to refraction of light. And this important term is incident ray. What is incident ray? Let us discuss over it. The ray of light that falls on the reflecting surface or interface of two medium is called incident ray. Similarly, reflected or refracted ray, here we have to learn the ray of light that is sent back by the reflecting surface into the same medium is called reflected ray. And third one is normal. The normal is a line at the right angle to the reflecting surface or to the refracting surface to the point of incidence. It is an imaginary line and is perpendicular to the reflecting surface or refracting surface. Next, angle of incidence. What is angle of incidence? So far we have learned about angle, incident ray and reflected ray. So in terms of incident ray and normals, we can define angle of incidence. So angle of incidence is defined as the angle made by the incident ray with the normal. This is called angle of incidence. Similarly, angle of reflection is defined as the angle made by the reflected ray with the normal, and it is denoted by R. An angle of incidence is denoted by I, letter I, and here it is denoted by letter R, a small r. Now, next thing is that object. What is object here? Because you know that in order to complete the vision process, there must be a source of light, there must be an object, and there must be a device that can receive the reflected light from the object and can interpret and then give the output as what type of that object is. So it means that there must be a source of light and an object there in the space or in a region, and there must be eye to observe that object. So when source of light sends ray of light to that object, then this ray of light get reflected to the eye, and then eye receives that reflected light, and corresponding electromagnetic signal is generated at the interface of retina and is then transmitted to the brain, and brain interpret about the object and gives output as what type of that object is. Now, next part is that so far we have to learn about object. What is object? Object is the thing that forms an image on the screen when it is illuminated or exposed to light. Now, what is image? It is the reflection of object on the screen is called image. It is the reflection of object on the screen is called image. Even you can say that projection of real object on the screen is called image. So image could be of two types, real image and virtual image. What is real image? Real image is that one which form directly on the screen by actual intersection of incident ray and refracted ray or reflected ray. On the other hand, virtual image or imaginary image, it is the image that cannot be obtained on the screen, and such kind of image is formed not by actual intersection of incident ray and reflected ray. Instead, it is formed by virtual intersection of incident ray and reflected.
सर
Yes.
यहाँ पर स्क्रीन क्या है?
Yes. What?
इस यहाँ पर जो स्क्रीन है डायरेक्टली ऑन द स्क्रीन, यहाँ पर स्क्रीन कैसा होता है?
स्क्रीन कैसा होता है ये देखना है आपको। जैसे आपकी शेडो दीवार पर बन रहा है तो दीवार स्क्रीन का काम कर रहा है, आप समझ रहे हो कि नहीं?
ओह यस सर,
और
यस सर।
अगर आपका इमेज प्लेन मिरर में बन रहा है तो प्लेन मिरर से जितनी दूरी पर इमेज बन रहा है उस जगह पर अगर कोई पर्दा डाल दे, कोई स्क्रीन, कोई पेपर रख दे तो स्क्रीन हो गई। तो वर्चुअल इमेज को हम स्क्रीन पर ट्रेस आउट नहीं कर सकते हैं, ठीक है। लेकिन रियल इमेज को हम स्क्रीन पर ट्रेस आउट कर सकते हैं। जैसे लेंस को रख दो और लेंस के सामने कोई रे ऑफ लाइट जाने दो, एंड लेंस की दूसरी तरफ आप देखोगे कि एक A4 साइज का पेपर कहीं पर एडजस्ट करोगे तो देखोगे कि रे ऑफ लाइट एक जगह कन्वर्ज कर रहा है एंड ब्राइटर पॉइंट बना रहा है, तो वो उसका इमेज हो गया सोर्स ऑफ लाइट का, और उसको हमने स्क्रीन पर आप समझ में आ गई बात। So now come to the point here. Virtual image is a type of image which is formed not by actual intersection of incident ray and reflected ray. Instead, it is formed by virtual intersection of incident ray and reflected ray. That means incident ray will be real, but reflected ray cannot be really intersecting. So when reflected ray produced backward, then it appears to be intersecting with incident ray. When both incident and reflected ray produced backwards, then at a point it appears to be intersecting, and at that point image is formed, and that could be the position of a screen. Now, law of reflection of light. There are two laws of reflection of light. Light obeys a certain basic laws while reflected from a smooth surface or shiny surface. So first law states that all the incident rays, normals and reflected rays lie in the same plane. This is the first law of reflection. And second law of reflection states that the angle of incidence is always equal to the angle of reflection. This is the second basic law. The incident, this is the second law, first law that is given below here. The incident ray, reflected ray and normal to the plane mirror or to the mirror at a point of incidence all lie in the same plane. This is the statements for the law of reflection. And the incident ray and reflected ray lie on either sides of the normal, not on the same sides. One more thing that you have to remember, that incident ray and reflected ray must lie on either side of normal. And here you see, this is the incident ray which incidents on the plane of the mirror. This is the mirror reflecting surface, and this red line is normal, which makes an angle of 90 degree with the plane mirror. And angle made by the incident ray with the normal is called angle of incidence, and angle made by the reflected ray with the normal is called angle of reflection. So here, if you geometrically interpret the things, you will come to know that this angle and this angle are equal. Because when you draw an imaginary line parallel to the surface of the mirror, here you draw here like this, then you will see that the two triangles are there on the same base. Therefore, applying the formula for the congruency, you will see that by specificity, the two angles are equal. So it is proved by that geometrically. Next one is that properties of image formed by the plane mirror. That is characteristics of image formed by the plane mirror. First property is that image formed by the plane mirror is always virtual and erect. This is not real image. Second one is that image formed by the plane mirror is of the same size as that of the object. And third characteristics of the image formed by the plane mirror is that image formed at the same distance from the mirror as the object is in front of the mirror. And last characteristics of the plane image formed by the plane mirror is that image formed by the plane mirror is laterally inverted. That is, left side of object will appear as right side in its image. This is called lateral inversion. Now, this was the plane mirror. Next one is the spherical mirror or concave or convex mirror. Although we have discussed a lot about it, just we are having a recap about the topics, and then we will enter into the topic refraction. And I have already shared a video clips regarding refraction. I hope that all of you must have gone through these videos and must have had the concept of refraction. Now here, a spherical mirror is a type of mirror which has curve reflecting surface. A spherical mirror is a type of mirror having curve reflecting surface, and it is a part of a sphere, hollow sphere, and silvered either sides. If it is silvered from outside, then it will have a reflecting surface inwards, and if it is silvered inside, then it will have a reflecting surface outward. Therefore, a spherical mirror could be of two types. First one is a concave mirror. It is a spherical mirror that has its reflecting surface curved inwards. It means a spherical mirror is silvered from outside and its reflecting surface is facing towards center of curvature. And next one is convex mirror. It is a spherical mirror that has its reflecting surface curved outwards and it is away from the center of curvature and it is silvered from inside. That's why its reflecting surface is outside. Now there are some important terms to be explained first in terms of a spherical mirror that is essential to know. Without knowing that, one cannot be able to explain all about the image and mirror formula and the spherical mirrors. It is important to know about that one. Center of curvature, first one. What is center of curvature? Second, focus or simply principal focus and principal axis, pole, focal length and radius of curvature. So I think that now center of curvature, let us understand about all this topic is to be discussed first. Term used to explain a spherical mirror. Center of curvature, which is denoted by C, is defined as the center of a sphere of which the mirror itself is a part. So far you must have understood it well. And then radius of curvature. If you learn about the center of curvature, then you can understand radius of curvature. Radius of curvature is defined as the radius of the sphere of which the mirror itself is a part. Next thing is that pole of the mirror, a spherical mirror. It is the center of the sphere, a spherical mirror. Remember here, it is not the center of curvature. It is center of a spherical mirror. That is a point on the reflecting surface. Just middle point or central point on the reflecting surface itself. It means if you take a spherical mirror and you drop a round ball, a spherical ball on this spherical surface, and you will see that this surface, this ball will come to rest at a point on the spherical surface exactly in between or in the central points. That is called pole. Here, by looking at the picture, this is the spherical mirror, and if you virtually imagine that if this spherical part is extended to complete a whole sphere like this, then center of this sphere will be called center of curvature. Center of curvature, as we have discussed here, it is denoted by C. Next thing is that we have to learn about pole. So this is the mirror, a spherical mirror. So central point of this spherical mirror is here, because this point divides the mirror in two equal parts. So this is central point. This is called pole. So central point on the spherical mirror itself is called pole of the mirror, and distance between the center of curvature and pole is called radius of curvature. You see here. In this case, this is a convex mirror because its reflecting surface is outside or away from the center of curvature, because it is silvered from inside. So it will reflect the ray outwards. So this is convex mirror. On the other hand, when it is silvered from outside, then it will have reflecting surface inwards directed toward the center of curvature. So it is called concave mirror. Now, focus and focal length of the spherical mirror. You know well that a spherical principal focus. First one, what is focus? So it is defined as a point on the principal axis where all the rays parallel to the principal axis appears to be converged. So first of all, you have to remember what is principal axis. Principal axis is an imaginary line passing through the center of curvature and pole of the mirror. Center of curvature and pole of the mirror, and is virtually extended up to infinity on either sides. This is called principal axis. Principal axis is always perpendicular to the reflecting surface. Therefore, principal axis itself acts as a normal. Now come to the point, focus of convex mirror. It is defined as the point on the principal axis where reflected ray appears to converge. Reflected ray appears to be converged at that point, or a ray coming parallel to the principal axis appears to be diverged out from a point on the principal axis, and that point is called focus of the convex mirror. Next topic is focal length of the mirror. So it is basically defined as the distance between the pole and principal focus of the mirror is called focal length of the spherical mirror, and it is denoted by English alphabet a small case. In a small case, that is a small f is used to represent focal length, and capital F is used to represent focus itself, principal focus. Now the radius of curvature is, this is the relation between focal length and radius of curvature. So far in the previous class or in the last class, we have discussed about relation between radius of curvature and focal length. So radius of curvature is 2 times, that is twice the focal length, that is r equal to 2f of any spherical mirror. Next, rules for reflection of light through a spherical mirror. We have discussed all this clearly, so no need to explain anymore. Do you think you need to explain it anymore? Yes.
No, sir. No,
Is
sir.
it essential to explain? Because
No, sir.
no. All right. So as we have already discussed about the, and also sent complete notes about all these things, so you don't need to explain it anymore. And all these things has already been discussed, so you don't need to discuss about that. And now come to the point. These all are the image formation about, and अब देखो कुछ लड़के अब यहाँ पे अपना शरारत शुरू कर दिया है, सो आई कांट अप्रूव. नाउ
क्या हुआ सर?
अब देखो, ये मिरर फॉर्मूला ऑलरेडी डिस्कस्ड ऑल, एंड मैग्निफिकेशन ये भी डिस्कस किया जा चुका है. इज इट एसेंशियल टू डिस्कस एनी मोर? नो. यस और नो?
No, sir.
No. Now come to the point. New topic is refraction. Okay, new topic is refraction. So you must understand about the refraction. Refraction of light. This is new optical phenomenon other than reflection. So refraction of light is defined as an optical phenomenon of bending of light when it travels from one medium to another medium. Okay, and uh, refraction phenomenon obeys two basic laws while passing from one medium to another medium, and refraction or bending of ray of light takes place at the interface of the two media interface of the two media. Now, law of refraction of light, that we have to understand. Just like refraction of light obeys two basic laws, and first law is similar to that of the uh, first law of reflection. Only difference is that in place of reflected ray, here we write refracted, and everything will remain same in first law. And law of refraction of light, first law of refraction of light states that the incident ray, the normal, and the refracted ray all lie in the same plane. So similar thing is there, everything is same. In place of reflected ray we must write here refracted ray. Now, second law is entirely different from the second law of reflection. So, you must remember it and be concentrated over the second law and memorize it again and again. Second law of refraction states that while light passing from one medium to another medium, then ratio of sine of angle of incidence to sine of angle of refraction is always constant. Okay, and that is sine I is to sine R equal to constant, and this constant is called refractive index or relative refractive index of first medium in comparison to second medium, or incident medium to that of the refractive medium. So here you can say that now come to the point
Sir,
here. Any problem?
sir, please explain it again.
Okay, and the same video lecture will be uploaded on YouTube, and you can view it again and again and draft notes. Second law states that while light making a transition from one medium to another medium, or in simple way, while light is uh, traveling from one medium to another medium, then at the interface or boundary of the two media, the ratio of sine of angle of incidence to sine of angle of refraction is just equal to constant, and this constant is nothing but what relative refractive index of the first medium relative to that of the second medium. Now here, and I think that in last class, in last day I have shared a video clips, and this video clips discussed all about the second law. Video clips, not digital notes I have shared. Now this is second law. Here sine is a trigonometric function, and this sine is a trigonometric function. I stands for angle of incidence, R stands for angle of refraction. So ratio of sine of angle
That's
of incidence to sine of angle of refraction is always constant. Even you can say that sine I proportional to sine R. Okay, and therefore sine I equal to constant into sine R, where constant is proportionality constant and is called refractive index. relative refractive index of that. So refractive index involved in the expression, so it is essential to define what is refractive index. As you know well that when light passes from one medium to another medium, then light bends either towards the normal or away from the normal. That is, a ray of light deviates from its actual path, and how it deviates depends on the property of the material medium, and that property can be mathematically measured as the ratio of a speed of light in one medium to that in second medium. And this ratio of a speed of light in one medium to that in second medium is called refractive index. And literally, refractive index is defined as the ability of the medium to bend the light while light passing from one medium to that medium. That is, when light passing from first medium to second medium, then ability of the second medium to bend the ray of light and the extent to which it can bend will measure the refractive index of that. So, mathematically, this ability of a medium to bend the ray of light is measured in two different ways. First one is, it can be measured in terms of a speed of light. So far you have already learned that when light passes from one medium to another medium, the speed of light changes. So if you measure the ratio of a speed of light, this ratio will give you a constant, and that constant is given or placed here. For a given pair of medium, this constant will remain constant as long as pair of medium is same. So one of the method to express refractive index is to find out the ratio of a speed of light in incident medium to a speed of light in refractive medium. Incident medium is those in which incident ray lies, and refractive medium is those in which refracted ray lies. So here diagram I will show you. And even so, refractive index is relative. If you see that light passes from first medium to second medium, then refractive index of the second medium with respect to first medium is expressed as the speed of light in first medium, is expressed as the ratio of a speed of light in first medium to that of speed of light in second. This is called refractive index of the second medium with respect to first medium. And even you can reverse the situation. If light make a transition from second medium to first medium, then refractive index is expressed as a speed of light in second medium to that in first medium, and it is expressed as V2 is to V1, where V1 and V2 is the speed of light in first medium and second medium. So here you see that if transition of light is reversed, refractive index will get reversed and will be reciprocal of first case. Now, next thing is that absolute refractive index. There we will talk about the two refractive index, relative refractive index and absolute refractive index. Absolute refractive index of a medium is defined as the refractive index of the medium with respect to vacuum or air. This is called absolute refractive index. As we know that a speed of light in vacuum is maximum and is denoted by C, and speed of light in any material medium is lower than that of the speed of light in vacuum. So, a speed of light in a material medium is denoted by V. So, absolute refractive index of any material medium is denoted by Nm here, but you must write here mu in your textbook, mu. It is denoted as a speed of light in air or in vacuum, a ratio of a speed of light in air or vacuum to that in a medium. So C upon V is defined as the absolute refractive index of any material medium. And here you see N to 1 is the refractive index of the medium 2 with respect to medium 1. And N12 is the refractive index of the medium 1 with respect to 2. And here, okay, let me see. I think that today's topic is over for